Hello everyone. So in this video, we are going to discuss a question based on minimax and alpha beta pruning, which was asked in GATE DA 2025 exam. Okay. So here you can see a question, simple question, which was asked for 2 marks. Okay. Now we already discussed many examples based on minimax algorithm and alpha beta pruning. So whatever the concept we have discussed, same thing you can apply here as well. So first read the question. Consider game tree 1 and tree 2 as shown below. Okay. The first level is max agent and second level is mean agent. So here you can see this is basically a max agent and this is basically a mean agent. Okay. The value in the square node is the output of the utility function. Okay. This is given to us. I hope everyone knows how this mean and how this max agent works. Okay. So these two trees are given to us. For what ranges of x and y? So we need to calculate x and y, the range of x and y, the right child node of B, this one, and the right child node of E, this one will be pruned by alpha beta pruning algorithm. Okay. Now when we talk about the alpha beta pruning algorithm, so here we are saying alpha deals with the max player and beta deals with the mean player. Okay. And if you see, when we prune the node and when we are going to prune the node, whenever this condition becomes true, so whenever alpha value is greater than or equals to beta value, then we are going to prune the node. Okay. Now this concept is enough to solve this particular question. Okay. So if you understand how minimax algorithm works and how this alpha beta pruning works, then you can solve any question. Just apply that particular concept. In GATE exam, they can ask the question in number of different ways. But if your concept is clear, if you know the basic, you can easily apply and solve those questions, right? So first, tree 1 is given to us here, right? So here you can see mean player, the utility value is 2. Max player is A, right? Now, if you observe, the right child node of B is pruned. It means what? What we can say about this particular thing? If this particular node is getting pruned, then at this particular node, what is the condition? This particular condition should satisfy at this particular node. Then only we can say we are going to prune that particular subtree. So here when I say alpha value greater than or equals to beta value, but at this moment the beta value is what? Because B node deals with the mean player. So if you go here, this is what? B, right? So what is the beta value in this case? Because if we see in the case of minimax or alpha beta pruning, we explore the node on the left side, like what we do in the case of our DFS, right? So here you can see here x. So I can say beta equals to x at this particular moment. But according to this condition, we are not going to prune the right subtree, right? And what about this max node A here, alpha value? Now here the beta value is what? Here beta value is 2, right? Now from here I'm going to get a beta value equals to 2. Now if we see here, if I go back here, alpha can be 2, right? Alpha can take the value 2. Now if alpha can be a 2, so what is this condition, right? So 2 greater than or equals to x, right? Because if we apply this particular condition, right? So what we can say about this particular thing? So whenever the value of x is less than 2, then we are going to prune the node. Okay, less than or equals to 2, then we are going to prune the node, right? It means what is the range of this particular x? So x belongs to what? Minus infinity to 2, right? So it can take any value less than 2, then only we are going to prune the L node, right? So simple concept of alpha beta pruning. If you practice it enough, you don't need to spend this much time. Just I'm explaining this particular concept and question, so we're going in detail. Otherwise, you can simply solve this question within 2 minutes. Okay. So here you can see x belongs to minus infinity to 2 because your alpha value is equals to 2 and beta from this particular thing is x, and we are going to prune this particular node. So this condition should be true. Alpha greater than equals to beta, and alpha value from this side we are going to get 2, and if we just put the values in our equation, our required thing, so 2 greater than equals to x, it means what? The value of x must be less than or equals to 2. It means what? The value of x less than or equals to 2 means the range of that particular x is what? Minus infinity to 2, right? If you see option A, B, C, D, only B and C are the ones in which we have that particular range, right? But now it depends on the value of y. Now let's apply the same concept to the tree 2 here as well. Okay. Now we are going to prune the right child node of this particular subtree E. So same thing here. We have mean player, right? So from this side, what we are going to get first, we'll go here. So value of beta is what? So this is alpha, this is beta. Here also we have beta player, right? So value of beta at this particular point is 5, right? Now if we prune this particular node, it means what? At this particular node, alpha is greater than equals to beta, condition is getting satisfied, then only we are going to prune this node, right? Now what's the beta value here from this particular case? If we go on this side, the value of beta will be 2, right? Because of the utility value function here 2. Now we got the beta value 2 here. Now we have alpha here. Now from this side, we have 5, beta equals to 5, but I don't know what is this y value is. So here what this particular node D will take, at node D, beta value will be what? Minimum of 5 and y, right? So this is what beta value we have at this particular node D, but already we know this node is getting pruned. So here beta value is 2. Now it means what? Alpha value is what? If beta value is 2, alpha value is what? Alpha value must be greater than 2, right? So for according to this condition, if beta value is equals to 2 at this particular point, because we are interested in pruning this node, so alpha value must be greater than 2. So here you can see alpha greater than or equals to 2, right? So that's it. So whenever the alpha value is greater than or equals to 2, we are going to prune that node. Now what value this particular y can take? Now what I said, at this particular node D, we have mean player. So it is going to take minimum value of 5 and between 5 and y, right? Now here if you see, y can take any values from 2 to infinity, right? Doesn't matter, right? If the value of y is 2, in that case the minimum value for this beta value will be what? 2, right? If you take y equals to 100, in that case minimum value from this particular node D and for this beta will be what? 5. So y can take any value between 2 to infinity, doesn't matter. It can be 2 to 1 lakh also. But anyway, this beta player is going to take the minimum, that is basically 5 in the extreme case, like this. Okay. So if you see the range of this y from this particular equation itself, y is what? Belongs to 2 to infinity. So here in this case, option C is correct. Simple question. I have taken this much time to explain the concept, but if you know that this particular concept, you can solve this question in less than 2 minutes during exam. Okay. The most important thing is to understand the concept first. Doesn't matter how many tree they will give, which type of tree they will give, what type of question they are going to ask. In alpha beta pruning, this is the only concept we have. Okay. So you can watch the videos based on Minimax algorithm and alpha beta pruning to have a better understanding of this particular topic. Okay. I hope you understand the video solution of this particular question. Thank you.